Take a deep breath in. Hold it for a moment. Now let it go slowly. Feel your shoulders drop. Feel the weight of your body settling into whatever supports you right now. You are about to take a journey through the universe. Not a frantic race through stars and galaxies. Not a lecture filled with complicated equations. Just a gentle drift through the most calming, most beautiful, most peaceful facts about the cosmos that surrounds us all. The universe is not in a hurry. It has been here for nearly 14 billion years. It will be here long after you and I are gone. And right now, in this moment, it is simply existing, expanding, breathing, moving at its own pace. You do not need to remember everything you hear tonight. You do not need to understand every concept completely. You do not need to stay awake until the end. This is not a test. This is not homework. This is simply an invitation to let your mind wander through space while your body finds rest. The universe is the largest thing we know. And yet, when you really think about it, the universe is also the most gentle thing we know. It operates according to laws that are consistent, predictable, reliable. The same gravity that holds planets in orbit is the same gravity that has always held planets in orbit. The same light that left distant stars millions of years ago is the same light that will leave those stars millions of years from now. There is something deeply comforting about that consistency. In a world where so much feels chaotic and unpredictable, the universe simply continues. Stars burn, planets orbit, galaxies slowly spin, and all of it happens whether we are watching or not. Tonight, we will explore the universe together. We will talk about stars that burn for trillions of years. We will talk about the empty spaces between galaxies. We will talk about light that has been traveling for so long that the stars that created it no longer exist. We will talk about clouds of gas that smell like raspberries. We will talk about the sound the universe made in its first moments. But we will talk about all of these things slowly, gently, with pauses for you to breathe, with reminders that you can close your eyes whenever you want, with the understanding that falling asleep is not a failure. It is exactly what this journey is designed to help you do. So find a comfortable position, adjust your pillow if you need to, pull your blanket a little higher, let your eyes close or stay open, whichever feels better right now. The universe is waiting, and it has been waiting for billions of years. It can wait a little longer while you settle in. Take another breath, a slow one, in through your nose, out through your mouth. Good. Let us begin. The universe began approximately 13.8 billion years ago. That number is so large that it is almost meaningless to us. Our brains are not built to comprehend billions of anything. But here is something that might help. If you compressed the entire history of the universe into a single year, with the Big Bang happening at midnight on January 1st, then human beings would not appear until December 31st at about 11:58 p.m. All of recorded human history would fit into the last few seconds before midnight. We are so new, so recent, so small in the timeline of everything that has ever happened. And yet here we are, lying in bed, breathing, thinking about the universe, made of atoms that were forged inside stars billions of years ago. You are not separate from the universe. You are part of it. Every atom in your body was once inside a star. Every breath you take contains atoms that were breathed by dinosaurs, by ancient humans, by people who lived centuries ago in places you will never visit. You are connected to everything, and right now, that connection does not require anything from you except rest. The universe is not asking you to solve its mysteries tonight. It is not asking you to understand quantum mechanics or calculate the speed of light. It is simply asking you to exist, to breathe, to let go of the day that just ended and prepare for the day that will come tomorrow. Scientists estimate that there are between 100 billion and 400 billion stars in our galaxy alone. Our galaxy is called the Milky Way. It is shaped like a flat disk with a bulge in the middle and several spiral arms extending outward. If you could look at it from above, it would look like a pinwheel. If you could look at it from the side, it would look like two fried eggs placed back to back. Our Sun is just one of those billions of stars. It is located about 2/3 of the way out from the center of the galaxy, on one of the spiral arms. It is not particularly special as far as stars go. It is medium-sized, medium-aged, medium bright. It is the kind of star that astronomers call unremarkable. And yet this unremarkable star has been burning steadily for about 4.6 billion years. It will continue burning for another 5 billion years or so. Every day, it converts about 600 million tons of hydrogen into helium. This process releases an enormous amount of energy, enough energy to warm a planet located 93 million miles away. Enough energy to make life possible. You have never met the Sun personally. You have never shaken its hand or had a conversation with it, but you owe your entire existence to it. Every bit of warmth you have ever felt, every plant that has ever grown, every breath of oxygen you have ever taken, all of it traces back to this medium-sized, unremarkable star that just happens to be in the right place at the right time. The Sun is not trying to keep you alive. It is simply doing what stars do, burning, existing, following the laws of physics that have governed its behavior for billions of years. And in doing so, it creates the conditions for you to lie here right now, safe, warm, breathing. Beyond our Sun, beyond our solar system, there are more stars than you could count in 1,000 lifetimes. If you tried to count every star in the Milky Way, counting one star per second, it would take you thousands of years. And the Milky Way is just one galaxy among hundreds of billions of galaxies. Some estimates suggest there are 2 trillion galaxies in the observable universe. Each galaxy contains billions or even hundreds of billions of stars. The total number of stars in the universe is larger than the number of grains of sand on all the beaches on Earth. And here is the beautiful part, the comforting part. Most of those stars are doing exactly what our Sun is doing, burning hydrogen, creating light, existing in the darkness of space. They are not worried about deadlines or relationships or money or health. They are simply burning, and they will continue burning long after you and I and everyone we know has returned to the atoms from which we came. There is something peaceful about that, about knowing that the universe continues whether we are paying attention or not, that stars burn in the darkness, that galaxies spin, that the laws of physics remain constant. You do not have to hold the universe together tonight. It is holding itself together just fine. Your only job right now is to rest. So let your breathing slow. Let your thoughts drift. Let the weight of your body sink deeper into your bed. The universe is vast. You are small. And that is okay. That is more than okay. That is exactly as it should be. Take another breath. Slower this time. The journey continues. But first, rest. Just for a moment. Or for the whole night. Either way, the universe will still be here tomorrow. And so will you. Let us talk about distance. Not the distance from your bed to your bathroom. Not the distance from your home to your workplace. Let us talk about the distances in space. The kinds of distances that make our earthly measurements seem almost laughably small. The distance from the Earth to the Moon is about 238,855 miles. That sounds like a lot. And it is. If you could drive to the Moon at highway speeds, never stopping, it would take you about 5.5 months to get there. But in cosmic terms, the Moon is right next door. It is practically in our backyard. The distance from the Earth to the Sun is much farther, about 93 million miles. Scientists call this distance 1 astronomical unit, or 1 AU. It is a useful measuring stick for distances in our solar system. Mars is about 1.5 AU from the Sunday. Jupiter is about 5.2 AU. Neptune, the farthest planet from the Sun, is about 30 AU away. But even Neptune is close by in cosmic terms. The edge of our solar system, where the Sun's influence begins to fade and interstellar space begins, is thought to be somewhere around 100,000 AU away. That is, about 9.3 trillion miles. Light travels fast. faster than anything else in the universe. Light travels at 186,282 miles per second. At that speed, light from the Sun takes about 8 minutes and 20 seconds to reach Earth. Light from the Sun takes about 4 hours to reach Neptune. But to reach the edge of our solar system, light takes about 17 hours. And to reach the nearest star beyond our Sun, light takes over 4 years. That nearest star is called Proxima Centauri. It is 4.24 light-years away. A light-year is the distance light travels in 1 year. It is about 5.88 trillion miles. So Proxima Centauri is about 25 trillion miles away from us. If you wanted to drive to Proxima Centauri at highway speeds, it would take you about 50 million years. If you wanted to walk there, it would take you about 800 million years. And that is the nearest star. Most stars in our galaxy are thousands or tens of thousands of light-years away. Some are hundreds of thousands of light-years away. Let your mind rest on that for a moment. The distances are so large that they stop being meaningful. They become abstract, theoretical, numbers on a page rather than actual distances you could ever hope to cross. And there is something strangely calming about that, about knowing that there are places so far away that you will never reach them, that no human will ever reach them, that the only way to visit them is in your imagination, in your dreams. You do not have to go anywhere tonight. You are exactly where you need to be. And the stars will remain in the sky, unreachable and perfect, whether you are watching them or not. Space is not just big. It is also mostly empty. If you took all the matter in the universe and spread it out evenly, there would be about 1 atom per cubic meter of space. 1 single atom in a space the size of a large closet. Everything else would be emptiness, vacuum, nothing. Even in our own solar system, which is relatively crowded by cosmic standards, most of the space is empty. If the Sun were the size of a basketball, Earth would be the size of a small bead, about 26 feet away. Jupiter would be the size of a golf ball, about 135 feet away. And Neptune would be the size of another small bead about 780 feet away. Everything else in between would be empty space, just darkness, just vacuum, just nothing. And the gaps between stars are even more extreme. If our Sun were the size of a basketball in New York City, the nearest star would be another basketball in Los Angeles. Everything in between would be emptiness. This emptiness is not a flaw. It is not a problem to be solved. It is simply the way the universe is. Most of space is space. Most of the universe is empty. And in that emptiness, stars and galaxies float like islands in an infinite ocean. There is something peaceful about empty space. It does not demand anything. It does not require maintenance. It does not change rapidly. It simply exists, quiet, still, dark. If you were floating in the empty space between stars, you would see almost nothing. A few distant points of light. The faint glow of galaxies too far away to resolve into individual stars. But mostly, you would see darkness. Deep, perfect, uninterrupted darkness. No sounds would reach you. Sound needs a medium to travel through. It needs air or water or some other substance to carry the vibrations from one place to another. In the vacuum of space, there is no medium, there is only silence. Complete silence. The kind of silence that never exists on Earth. Even in the quietest room, you can hear the sound of your own breathing, the beating of your own heart. But in space, there would be nothing. Just you and the darkness and the silence. It sounds lonely, and perhaps it would be. But there is also something almost meditative about it, about being surrounded by nothing, about having no distractions, no interruptions, just existence in its purest form. You do not have to go to space to find quiet. You can find it right here, right now, in this moment. Close your eyes if they are not already closed. Listen to the silence between your breaths. Feel the stillness of your body. The emptiness of space is not a void. It is a canvas, a background against which stars and galaxies appear. Without the emptiness, there would be nothing to contrast with the light. Without the darkness, the stars would not shine, and without the quiet moments, you would never find rest. The universe is bigger than we can see. This is not because our telescopes are not powerful enough. It is because light has not had enough time to reach us from the farthest parts of the universe. Remember, light travels at a finite speed, very fast, but still finite, and the universe is only about 13.8 billion years old. That means light from the most distant parts of the universe has only had 13.8 billion years to travel toward us. Anything farther away than that, we simply cannot see. The light has not reached us yet. It may never reach us, because the universe is expanding. Space itself is stretching, carrying distant galaxies away from us, faster than light can travel through that expanding space. The edge of the observable universe is about 46.5 billion light-years away in all directions. That gives us a sphere of visibility, with a diameter of about 93 billion light-years. Everything inside that sphere we can theoretically observe. Everything outside that sphere is beyond our view. But here is the thing. The observable universe is not the entire universe. It is just the part we can see. The actual universe is almost certainly much larger. It might be infinite. It might extend forever in all directions, with galaxies and stars and planets continuing on without end. We will never know how big the entire universe is. We are limited by the speed of light and the age of the universe. We can only see a finite portion of what exists. And there is something strangely comforting about that. About knowing that there are mysteries we will never solve, questions we will never answer, horizons we will never cross. You do not have to understand everything. You do not have to see everything. You do not have to know everything. It is okay to live with mystery. It is okay to accept that some things are beyond your reach. The universe is content to keep its secrets. And you can be content to rest in the small corner of it that you call home. Breathe slowly. Let your mind drift. The universe is vast, but you are safe here. In this moment, in this place. Stars are not eternal. They are born, they live, they die, but their lifespans are so long compared to ours that they might as well be eternal. A star can live for billions or even trillions of years, long enough to watch civilizations rise and fall countless times, long enough to outlast every memory of everything that has ever happened on Earth. Stars are born in nebulae. These are enormous clouds of gas and dust floating in space. They can be hundreds of light years across. They contain enough material to make thousands or even millions of stars. Most of the gas in a nebula is hydrogen, the simplest element, the most common element in the universe. Each hydrogen atom consists of just one proton and one electron. Simple, basic. But when you gather enough hydrogen together in one place, something remarkable happens. Gravity begins to pull the hydrogen atoms together, slowly at first. Over thousands of years, the cloud begins to collapse. As it collapses, it gets denser. And as it gets denser, it gets hotter. The process is gentle, patient. There is no rush. The cloud has all the time in the universe. It collapses slowly, steadily, inevitably. Eventually, the center of the cloud becomes dense enough and hot enough that hydrogen atoms begin to fuse together. When two hydrogen atoms combine, they form helium. And when they do, they release energy, a lot of energy. This is nuclear fusion, the process that powers every star in the universe. Hydrogen fuses into helium, releasing light and heat and radiation. The process is self-sustaining. The energy released by fusion keeps the core of the star hot enough to continue fusion. And the fusion continues as long as there is hydrogen to burn. A star is born. The process from the beginning of the collapse to the ignition of fusion can take millions of years. There is no moment where the star suddenly turns on like a light switch. It is gradual. A slow brightening, a gentle warming. Eventually, the new star begins to glow, first dimly, then brighter. It clears away the remaining gas and dust around it, revealing itself to the universe. And once it begins burning, It can burn for billions of years. Think about that for a moment. A star spends millions of years being born, then it spends billions of years simply existing, burning hydrogen, creating light, warming any planets that might orbit it. There is no hurry, no deadline, no rush to finish. The star simply burns at the rate it burns, and it will continue burning until it runs out of fuel. You do not have to hurry either. You do not have to rush. You can take your time. You can exist at your own pace. Close your eyes. Breathe slowly. Imagine a cloud of gas collapsing slowly over millions of years. Imagine the gradual warming, the patient process, the gentle birth of something that will last for billions of years. You are allowed to be patient with yourself. You are allowed to take as long as you need. Once a star is born, it settles into a long, stable period of burning. For most stars, this period lasts billions of years. Our Sun, for example, has been in this stable phase for about 4.6 billion years. It will remain in this phase for another 5 billion years or so. During this time, very little changes. The star burns hydrogen at a steady rate. It produces light at a steady brightness. It maintains a steady temperature, day after day, year after year, century after century, millennium after millennium. Nothing dramatic happens. No explosions, no sudden changes, just the quiet, consistent burn of nuclear fusion deep in the star's core. This phase of a star's life is called the main sequence. Most of the stars you see in the night sky are in their main sequence phase. They are simply burning hydrogen, existing, doing what stars do. There is something deeply peaceful about this, about the idea of something burning steadily for billions of years, never rushing, never slowing down, just maintaining a perfect balance between the inward pull of gravity and the outward push of the energy produced by fusion. If gravity was slightly stronger, the star would collapse. If the energy from fusion was slightly stronger, the star would expand. But in a stable star, these forces are perfectly balanced. The star is in equilibrium. It is content to exist exactly as it is for billions of years. Inside a star like our Sun, the conditions are extreme. The core temperature is about 15 million degrees Celsius. The pressure is enormous. Atoms are stripped of their electrons, existing as bare nuclei in a soup of plasma. Energy from the core slowly works its way outward, taking thousands of years to travel from the center of the star to its surface. But on the surface, the star is relatively calm. The Sun's surface temperature is about 5,500 degrees Celsius. Hot by our standards, but cool compared to the core. And the light that leaves the surface and travels through space is gentle, warm, life-giving. This is what a star does. It takes the violent, extreme conditions of nuclear fusion and converts them into steady, reliable light and heat. It transforms chaos into order, energy into warmth. Every star is doing this right now. Every star in the sky is engaged in this same process, burning hydrogen, creating light, existing in perfect balance. And they will continue doing this long after you fall asleep tonight, long after you wake up tomorrow, long after you live your entire life. The stars will keep burning, steady, reliable, constant. You do not need to monitor them. You do not need to check on them. They are fine. They will continue being fine. And so can you. Let your breathing match the steady rhythm of starlight. Slow, consistent, reliable. In, out, in, out. The stars are burning. You are breathing. Everything is continuing as it should. Eventually, every star runs out of hydrogen in its core. When that happens, the fusion reactions begin to slow down. The energy pushing outward decreases, and gravity begins to win. For small stars, stars with less mass than our Sun, this process is very gentle, very slow, very peaceful. As the hydrogen runs out, the star begins to shrink. As it shrinks, the outer layers get hotter and expand. The star becomes what we call a red giant. It is larger than it was before, but cooler on the surface. It glows with a reddish light. This phase can last for billions of years. The star is not dying quickly. It is fading slowly, gradually, like a candle burning down over a very, very long time. Eventually, the outer layers drift away into space. They form a planetary nebula, a shell of glowing gas expanding slowly away from the dying star. The nebula is often beautiful, colorful, intricate. It can last for thousands of years before it disperses completely into the surrounding space. What remains at the center is the core of the star, no longer producing energy through fusion, just a dense ball of carbon and oxygen, slowly cooling. This is called a white dwarf. A white dwarf is incredibly dense. A teaspoon of white dwarf material would weigh several tons on Earth, but it is also very small, about the size of Earth, and it is no longer burning. It is just radiating away the heat it accumulated over its lifetime. This cooling process takes a long time, a very, very long time, longer than the current age of the universe. Scientists estimate that it takes tens of billions of years for a white dwarf to cool completely. Eventually, it will become a black dwarf, a cold, dark, inert lump of matter floating in space. But no black dwarfs exist yet. The universe is not old enough. Every white dwarf that has ever formed is still cooling, still glowing faintly, still radiating heat into the darkness. There is something beautiful about that, about the idea that even in death, stars take their time. They do not disappear suddenly. They do not wink out of existence. They fade slowly, over billions of years, giving the universe time to adjust, time to say goodbye. The smallest stars, the red dwarfs, burn even more slowly. They are so small and cool that they burn their hydrogen very efficiently. They can live for trillions of years, longer than any other type of star, longer than the universe has currently existed. In fact, no red dwarf has ever died, not a single one. Every red dwarf that has ever formed is still burning, still in its main sequence phase, still quietly fusing hydrogen in its core. They will continue burning for trillions of years into the future, long after our sun has died, long after every planet in our solar system has been destroyed or flung into interstellar space. The red dwarfs will still be burning, patient, steady, eternal. Well, not truly eternal, but close enough that the difference does not matter. Let yourself be like a red dwarf, slow, steady, in no hurry, burning gently, existing peacefully, taking all the time you need. Your eyes are getting heavy, your breathing is slowing, your thoughts are drifting. The universe is in no hurry, and neither are you. Our galaxy, the Milky Way, is home to somewhere between 100 billion and 400 billion stars. The exact number is difficult to pin down because many stars are hidden behind dust clouds or are too dim to see clearly. But even at the low estimate, 100 billion is an almost incomprehensible number. If you tried to count all the stars in the Milky Way, counting one star per second without ever stopping, it would take you more than 3,000 years to finish. And that is assuming you never sleep, never eat, never take a break. The Milky Way is shaped like a flat disk with a bulge in the middle and several spiral arms extending outward. The disk is about 100,000 light-years across and about 1,000 light-years thick. The central bulge is thicker, about 10,000 light-years across in all directions. Our Sun is located about 26,000 light-years from the center of the galaxy, about 2/3 of the way out from the center to the edge. We are on one of the spiral arms, called the Orion Arm or the Orion Spur. The entire galaxy is rotating. Every star, every planet, every cloud of gas is moving in orbit around the galactic center. Our Sun takes about 225 million years to complete one orbit. The last time we were in this exact position in the galaxy, dinosaurs were beginning to dominate the Earth. The next time we complete an orbit, who knows what the Earth will look like? The galaxy rotates slowly, patiently. There is no rush. Each star moves at its own speed, determined by its distance from the center and the mass of everything inside its orbit. Stars closer to the center move faster. Stars farther out move slower. But even at their fastest, stars are moving through space at speeds that make our fastest spacecraft look like they are standing still. The Sun is moving through the galaxy at about 514,000 miles per hour. And yet, relative to the other stars around us, we appear almost stationary. The galaxy is so large that even tremendous speeds seem slow by comparison. On a dark, clear night, if you are far from city lights, you can see the Milky Way stretching across the sky. It looks like a faint, cloudy band of light. That band is the combined light of billions of stars, too far away and too faint to see individually, but bright enough together to create a soft glow. People have looked up at the Milky Way for thousands of years. Ancient civilizations told stories about it. Some said it was a river of milk spilled across the sky. Some said it was a path for souls traveling to the afterlife. Some said it was the backbone of the night. They did not know what it really was. They did not have telescopes. They did not understand that each point of light was a distant sun. But they still found it beautiful. They still found it comforting. They still looked up at it and felt connected to something larger than themselves. You can do the same. Even if you cannot see the Milky Way from where you are right now, you can imagine it. A river of stars, a soft glow stretching across the darkness. Billions of suns, each one burning steadily, each one existing in its own corner of the galaxy. And you are part of it. You are made of atoms that were forged inside some of those stars. You are connected to the galaxy in a very real, very physical way. Take a breath. Let that connection settle into your thoughts. You are not separate from the universe. You are part of it. A small part, yes, but a part nonetheless. The Milky Way is not alone. There are hundreds of billions of galaxies in the observable universe. Perhaps as many as 2 trillion. Each one contains billions or hundreds of billions of stars. Some galaxies are shaped like spirals, with arms extending out from a central bulge. Others are elliptical, shaped like smooth ovals or spheres. Still others are irregular, with no clear structure, just a collection of stars and gas held together by gravity. The nearest large galaxy to the Milky Way is called Andromeda. It is about 2.5 million light-years away. That sounds incredibly far, and it is. Light from Andromeda takes 2.5 million years to reach us. When you look at Andromeda, you are seeing it as it was 2.5 million years ago. But in cosmic terms, Andromeda is close. It is part of our local group, a collection of about 54 galaxies that are all relatively near each other. The Milky Way and Andromeda are the 2 largest galaxies in the local group. The rest are smaller, dwarf galaxies that orbit around us, like moons orbit planets. Andromeda and the Milky Way are moving toward each other. Gravity is pulling them together. In about 4.5 billion years, they will collide. But do not worry. When galaxies collide, they do not smash together like cars in a crash. They merge slowly, gently, over millions of years. The stars are so far apart that individual stars almost never collide. Instead, they pass by each other, their orbits gradually rearranging as the 2 galaxies blend into one. The resulting galaxy will be larger than either the Milky Way or Andromeda alone. Some scientists have nicknamed it Milkomeda. It will be an elliptical galaxy, with stars orbiting in all different directions, rather than in a flat disk. By the time this happens, the Sun will be near the end of its life. It will have expanded into a red giant, likely engulfing the inner planets. Earth, if it still exists, will be a lifeless cinder. But the stars will continue. They will continue burning, continue moving, continue existing in whatever new arrangement the merged galaxy creates. Galaxies collide all the time. Throughout the universe, galaxies are merging, blending, creating new structures. It is a slow process, a gentle process, nothing sudden or violent. Just gravity doing what gravity does, pulling things together over billions of years. Beyond our local group, there are clusters of galaxies, collections of hundreds or even thousands of galaxies, all held together by gravity. The nearest large cluster is called the Virgo cluster. It is about 65 million light-years away and contains more than 1,300 galaxies. Beyond the Virgo cluster, there are superclusters. These are collections of clusters spanning hundreds of millions of light-years. Our local group is part of the Virgo supercluster, which contains dozens of galaxy clusters and spans about 110 million light-years. And beyond the superclusters, there are even larger structures, filaments and walls of galaxies, separated by enormous voids where almost no galaxies exist. The universe, on the larger scales, looks like a cosmic web, threads of galaxies connected by gravity, with vast empty spaces in between. All of this structure formed over billions of years. Slowly, gradually, gravity pulling matter together, one atom at a time, until enough matter accumulated to form stars, then galaxies, then clusters, then superclusters. The universe is patient. It builds slowly. It does not rush. And the result is a structure so vast, so complex, so beautiful, that we are still discovering new parts of it. Let your mind rest on that image. A web of galaxies, threads of light stretching across the darkness, billions of years of slow, patient construction. You do not have to build anything tonight. You do not have to create anything. You can simply rest and let the universe continue building itself. The universe is expanding. This is one of the most important discoveries in all of astronomy, and it is also one of the most calming. Space itself is stretching. The distance between galaxies is slowly increasing, not because the galaxies are moving through space, but because the space between them is expanding. Imagine a balloon with dots drawn on it. As you blow up the balloon, the dots move farther apart, but the dots are not moving across the surface of the balloon. The surface itself is expanding, carrying the dots with it. That is what is happening to the universe. The galaxies are like the dots. Space is like the surface of the balloon, and everything is slowly, gently stretching apart. This expansion is very slow on human timescales. You cannot see it happening. You cannot feel it. It does not affect your daily life in any noticeable way. But over millions and billions of years, the effect is significant. Distant galaxies are moving away from us. The farther away they are, the faster they appear to be receding. Not because they are moving faster, but because there is more space between us and them. And all of that space is expanding. Eventually, billions of years from now, most galaxies will be so far away that their light will no longer be able to reach us. The universe will appear emptier, darker. Our local group of galaxies will remain together, held by gravity. But everything else will fade into the distance, disappearing beyond the horizon of what we can see. But that will not happen for a very long time. For now, the universe is full of galaxies, full of stars, full of light, and the expansion is just part of the natural rhythm of the cosmos. There is something peaceful about expansion, about knowing that the universe is not static. It is changing, growing, stretching, but doing so slowly, gently, without rush or urgency. You can expand too, not physically, of course, but mentally, emotionally. You can grow, you can change, and you can do it slowly, at your own pace, without rushing. Breathe in, feel your lungs expand. Breathe out, feel them contract, in and out. Expansion and contraction, the same rhythm the universe follows. You are part of the universe, and the universe is part of you. Light is fast. It is the fastest thing in the universe. Nothing can travel faster than light, and yet, light still takes time to travel from one place to another. Light from the sun takes about 8 minutes and 20 seconds to reach Earth. That means when you look at the sun, you are seeing it as it was 8 minutes ago, not as it is right now. The light that is hitting your eyes left the sun's surface more than 8 minutes in the past. If the sun suddenly vanished, we would not know for 8 minutes. We would continue seeing it, continue feeling its warmth, for 8 more minutes. Then suddenly, the light would stop, the sky would go dark, and we would know that something had happened. But the sun is not going to vanish. It is going to continue burning for billions of years. The light you see from the sun today is the same light that humans have been seeing for thousands of years. The same light that warmed the dinosaurs. The same light that has illuminated every moment of life on Earth since life began. Light from other stars takes much longer to reach us. Light from Proxima Centauri, the nearest star, takes about 4 years. That means, when you look at Proxima Centauri, you are seeing it as it was 4 years ago. Light from stars in the Andromeda galaxy takes 2.5 million years to reach us. When you look at Andromeda, you are seeing it as it was before humans existed, before our ancestors walked the Earth, before civilization, before language. Light from the most distant galaxies we can see has been traveling for more than 13 billion years. It left those galaxies when the universe was young, when stars were just beginning to form, when galaxies were smaller and closer together. That light has been traveling through space all this time, crossing unimaginable distances, passing through empty space, past other galaxies, past stars and planets and nebulae, and finally, after billions of years, it reaches us. It enters our telescopes, and we see a glimpse of the ancient universe. Think about that for a moment. Light that left a distant galaxy 13 billion years ago has been traveling all that time just to reach us. And we happen to be here, right now, in the exact position to receive it, to see it, to study it. It is a kind of cosmic connection, a message from the ancient past, a signal that has been traveling longer than our planet has existed, and it arrives here, now, in this moment. You are connected to the distant past through light. The light you see from distant stars is old, ancient. It carries information about a time and place you will never visit, but you can still see it, still appreciate it, still marvel at it. Close your eyes for a moment. Think about light traveling through space, crossing the darkness, moving at incredible speed, but still taking years, centuries, millennia to reach its destination. Light is patient. It does not rush. It simply travels. And eventually, it arrives. You can be patient too. You do not have to rush. You can take your time, and eventually, you will arrive where you need to be. The light we can see is only a small fraction of all the light that exists. Our eyes are sensitive to what we call visible light, the light that appears to us as colors ranging from red to violet. But there are many other types of light that we cannot see. Beyond red, there is infrared light. Infrared is slightly less energetic than red light. We cannot see it with our eyes, but we can feel it as heat. When you stand in the sunlight and feel warmth on your skin, you are feeling infrared light. Beyond violet, there is ultraviolet light. Ultraviolet is slightly more energetic than violet light. We cannot see it, but it can affect our skin, causing sunburns if we are exposed to too much of it. Beyond ultraviolet, there is X-ray light, even more energetic, used in medical imaging to see inside the body. Beyond X-rays, there is gamma-ray light, the most energetic form of light, produced by the most violent events in the universe, like supernova explosions and black holes. On the other end of the spectrum, beyond infrared, there are microwaves. And beyond microwaves, there are radio waves. Radio waves are the least energetic form of light, but they can travel through space just like visible light. All of these forms of light are really the same thing: electromagnetic radiation, waves of electric and magnetic fields oscillating through space. The only difference is the wavelength and the energy. Visible light has wavelengths that our eyes can detect. Other forms of light have wavelengths that are too long or too short for our eyes to see. Stars emit all kinds of light, not just visible light. Our sun emits infrared, ultraviolet, X-rays, radio waves, all of it streaming out from the sun's surface, spreading through space in all directions. Some stars emit more ultraviolet light than visible light. Some emit more infrared. The color and type of light a star emits depends on its temperature. Hot stars emit more blue and ultraviolet light. Cool stars emit more red and infrared light. When we look at the universe through different types of light, we see different things. A galaxy that looks beautiful in visible light might look completely different in infrared or X-rays. Clouds of gas that are invisible to our eyes glow brightly in radio waves. Black holes, which emit no visible light, can be detected by the X-rays produced by matter falling into them. The universe is full of light we cannot see. It is all around us, passing through us, carrying information about distant stars and galaxies. We just need the right instruments to detect it. There is something humbling about that, about knowing that our eyes only show us a small fraction of what is really there, that there is more to the universe than what we can see directly. You do not have to see everything to appreciate it. You do not have to understand everything to find it beautiful. Sometimes, just knowing that there is more out there, more than you can perceive, is enough. Let that thought settle. The universe is richer and more complex than you can see, and that is okay. You do not need to see everything. You do not need to understand everything. You just need to rest. There is a very special type of light that fills the entire universe. It is called the cosmic microwave background, or CMB. It is the oldest light in the universe, light that has been traveling for more than 13 billion years. The CMB was created about 380,000 years after the Big Bang. Before that time, the universe was so hot and dense that light could not travel freely. Atoms were constantly being torn apart by the intense heat. Electrons were ripped away from protons. Light was constantly being absorbed and re-emitted, unable to travel more than a tiny distance before being absorbed again. But as the universe expanded, it cooled. Eventually, it cooled enough for electrons to combine with protons and form neutral atoms. When that happened, light was suddenly free to travel. It was no longer constantly absorbed and re-emitted. It could move through space unimpeded. That light has been traveling ever since. It has been stretched by the expansion of the universe, shifting from visible light to infrared light to microwave light. But it is still there, everywhere, filling all of space. If you could see microwave light, the entire sky would glow with a faint, uniform brightness. Every direction you looked, you would see this ancient light. Light from the early universe. Light that has been traveling for 13.8 billion years. The CMB is incredibly uniform, almost perfectly smooth, but not quite. There are tiny variations in temperature, tiny ripples in the light. These ripples represent tiny differences in density in the early universe. Regions that were slightly denser than average eventually collapsed under gravity to form the first stars and galaxies. So the CMB is not just ancient light. It is a map of the early universe. A snapshot of what the universe looked like when it was just 380,000 years old. By studying the CMB, scientists can learn about the conditions in the early universe. How hot it was, how dense, how it was distributed. The CMB is a kind of cosmic background hum, a reminder that the universe had a beginning, that it was once very different than it is now, that everything changes given enough time. But the change is slow, gradual. The universe does not rush. It has been expanding and cooling for nearly 14 billion years, and it will continue expanding and cooling for billions of years more. There is no urgency, no deadline, just the slow, steady progression of time. You can be slow and steady too. You do not have to hurry. You can take your time. You can rest. The cosmic microwave background has been traveling for 13.8 billion years. It can wait a little longer while you close your eyes and breathe. Nebulae are clouds of gas and dust in space. They are enormous, often hundreds of light years across. They are also some of the most beautiful objects in the universe. Some nebulae are bright and colorful. They glow with light from nearby stars or from the gas itself. Others are dark, blocking the light from stars behind them, appearing as dark patches against the brightness of the Milky Way. There are different types of nebulae. Emission nebulae glow because the gas inside them is heated by nearby stars. The gas becomes ionized, meaning electrons are stripped from atoms, and when those electrons recombine with atoms, They emit light. Different elements emit different colors. Hydrogen emits red light. Oxygen emits green or blue light. Sulfur emits red light as well. Reflection nebulae do not emit their own light. Instead, they reflect light from nearby stars. The dust in the nebula scatters the light, often giving the nebula a blue color, similar to why Earth's sky is blue. Dark nebulae are clouds of dust so thick that they block light from passing through them. They appear as dark patches or tendrils against the background stars. The most famous dark nebula is the Horsehead Nebula, a dark silhouette shaped like a horse's head against a bright emission nebula. Planetary nebulae are shells of gas ejected by dying stars. Despite the name, they have nothing to do with planets. Early astronomers thought they looked like planets through their telescopes, hence the name. Planetary nebulae are often symmetrical, with intricate structures, rings, shells, spirals. Each one is unique, shaped by the way the dying star ejected its outer layers. Supernova remnants are the expanding shells of gas left behind after a massive star explodes. These nebulae are often filamentary, with thin strands of glowing gas spreading outward from the explosion site. The Crab Nebula is a famous example. It is the remnant of a supernova that was observed by Chinese astronomers in 1054 AD. The gas is still expanding today, more than 900 years later. Nebulae are both birthplaces and graveyards. Some nebulae are regions where new stars are forming. The gas collapses under gravity, forming dense cores that eventually ignite and become stars. Other nebulae are the remains of stars that have died, their outer layers shed into space, returning material to the cosmos to be recycled into future generations of stars. It is a cycle. Matter is never destroyed. It is only transformed. The atoms in a nebula might have once been inside a star. Before that, they might have been in a different nebula. Before that, in a different star. On and on, cycling through the universe for billions of years. You are part of that cycle too. The atoms in your body were once inside stars. They were forged in the cores of those stars, then scattered into space when the stars died. They became part of a nebula, then part of a planet, then part of you. You are made of stardust, literally. And when you die, your atoms will continue. They will be recycled, used again, incorporated into something new. There is something peaceful about that, about knowing that you are part of a larger cycle, that nothing is truly lost. Everything continues, in one form or another. Breathe slowly. Think about the nebulae, clouds of gas glowing in the darkness, slow, patient, existing for millions of years, changing gradually. No rush, no urgency. You can be like a nebula, existing, changing slowly, taking your time. When a massive star dies, it can leave behind a very strange object called a pulsar. A pulsar is a neutron star that spins very rapidly and emits beams of radiation from its magnetic poles. A neutron star is incredibly dense. It is the collapsed core of a star that has exploded in a supernova. All the matter that was once in the core has been compressed into a sphere about 20 kilometers across. A teaspoon of neutron star material would weigh about 1 billion tons. Neutron stars are made almost entirely of neutrons, hence the name. The gravity is so strong that protons and electrons are forced together to form neutrons. The surface is solid, made of iron nuclei and electrons. Below the surface, the matter becomes stranger. Neutrons packed together so tightly that they almost touch. Some neutron stars spin very rapidly. The fastest known pulsar spins 716 times per second. That means its surface is moving at a significant fraction of the speed of light, and yet it is stable. The neutron star is so dense, so strong, that it can spin this fast without flying apart. As a neutron star spins, it emits beams of radiation from its magnetic poles. These beams sweep across space like the beams from a lighthouse. If the beams happen to point toward Earth as the neutron star spins, we see a pulse of light, then darkness, then another pulse, on, with perfect regularity. The first pulsar, was discovered in 1967 by Jocelyn Bell Burnell. She noticed a strange signal in her radio telescope data, a pulse that repeated every 1.33 seconds, perfectly regular, like a clock. At first, some scientists wondered if it might be a signal from an alien civilization. The regularities seemed almost too perfect to be natural. But as more pulsars were discovered, it became clear that they were a natural phenomenon, spinning neutron stars, flashing like cosmic lighthouses. Pulsars are incredibly precise timekeepers. The pulses are so regular that they can be used as clocks. Some pulsars are more accurate than the best atomic clocks on Earth. They pulse with such regularity that scientists can use them to detect tiny changes in the fabric of space-time itself. There is something calming about pulsars, about the idea of a star spinning in the darkness, flashing with perfect regularity, maintaining its rhythm for millions of years. No matter what else happens in the universe, the pulsar keeps spinning, keeps flashing, keeps time. You do not have to keep time tonight. You do not have to watch the clock or worry about schedules. You can just be, existing, breathing, letting time pass at its own pace. The pulsars are keeping time. They will continue keeping time while you sleep, while you dream, while you rest. You can let go of time, just for tonight, just for now. The spaces between galaxies are some of the emptiest places in the universe. In these voids, there are very few stars, very few galaxies, very little of anything. If you were floating in intergalactic space, far from any galaxy, you would see almost nothing. A few distant points of light from the nearest galaxies, but mostly just darkness, deep, profound, uninterrupted darkness. The density of matter in intergalactic space is incredibly low. On average, there is about 1 atom per cubic meter. In some voids, the density is even lower. 1 atom per 10 cubic meters, per 100 cubic meters. These voids are not completely empty. There is some gas, some dust, a few stray atoms floating through space, but compared to the density of matter inside galaxies, the voids are essentially empty, and they are enormous. Some voids are hundreds of millions of light-years across, larger than entire superclusters of galaxies. Crossing one of these voids, even at the speed of light, would take hundreds of millions of years. There is something almost overwhelming about that emptiness, about the sheer scale of nothingness. But there is also something peaceful. In the voids, nothing happens. There are no supernovae, no star formations, no colliding galaxies, just emptiness, quiet, stillness. It is the ultimate silence, the ultimate stillness, a place where you could float for eternity and never encounter anything. Of course, you cannot actually go there. And even if you could, it would not be a pleasant experience. The isolation would be total, the darkness, absolute. But there is something appealing about the idea, about a place where nothing demands your attention, where there are no distractions, no interruptions, just you and the emptiness. You can find a version of that here, right now. Close your eyes. Let the thoughts fade. Let the worries drift away. Create a quiet space inside your mind, a void where nothing needs to happen, where you can simply exist without demands or expectations. The voids between galaxies have been empty for billions of years. They will remain empty for billions of years more. They are patient, they are still, they are content to be nothing. You can be patient too. You can be still. You can be content with rest. Breathe slowly. Let the emptiness settle around you, not a frightening emptiness, a peaceful one, a restful one. The voids are waiting. And so is sleep. Time is strange in the universe. We measure our lives in years. A human lifetime is usually less than a century. That seems like a long time to us, but in cosmic terms, a century is nothing, less than a blink of an eye. The universe is about 13.8 billion years old. To put that in perspective, if the entire history of the universe were compressed into a single year, with the Big Bang happening at midnight on January 1st, the Earth would not form until September. The first simple life on Earth would appear in late September. The first complex life would not appear until mid-December. Dinosaurs would appear on December 25th. They would go extinct on December 30th. All of human history would fit into the last few seconds before midnight on December 31st. We are so new, so recent. The universe existed for more than 9 billion years before the Earth even formed. Stars were born and died. Galaxies formed and collided. The cosmos was active and vibrant for billions of years before our planet came into existence. And the universe will continue long after we are gone. The sun will burn for another 5 billion years. After that, it will expand into a red giant, engulf the inner planets, and eventually shed its outer layers to become a white dwarf. That white dwarf will cool slowly over tens of billions of years. Other stars will continue burning. Some will burn for trillions of years. The smallest red dwarfs will outlast every other star, burning slowly, efficiently, for timescales that make the current age of the universe seem short. Eventually, all stars will die. In the very distant future, perhaps 100 trillion years from now, the last star will burn out. The universe will go dark. No more starlight, no more warmth. Just the faint glow of cooling white dwarfs and the cold radiation left over from the Big Bang. But even then, the universe will continue. Black holes will slowly evaporate through a process called Hawking radiation. This will take an unimaginably long time. A black hole with the mass of the Sun would take about 1067 years to evaporate. That is a 1 followed by 67 zeros, a number so large it is meaningless to us. Eventually, even the black holes will be gone. And the universe will be filled only with the faintest particles, photons, neutrinos, a few stray electrons, all of it spreading farther and farther apart as the universe continues to expand. This is sometimes called the heat death of the universe, not because it gets hot, but because all the energy will be evenly distributed. No differences in temperature, no way to do work, no way to create structure or complexity. Just a cold, dark, empty universe. But that will not happen for an incomprehensibly long time. For now, the universe is full of stars, full of light, full of activity, and it will remain that way for billions and trillions of years to come. There is no rush. The universe is patient. It has all the time in the world, literally. You can be patient too. You do not have to hurry. You do not have to rush through life. You can take your time. You can move at your own pace. The universe is not watching the clock, and neither should you. The universe operates according to laws, not human laws that can be changed or broken, but physical laws, rules that govern how matter and energy behave. These laws are consistent. They apply everywhere in the universe. The same laws that govern the motion of planets around our sun also govern the motion of planets around distant stars in distant galaxies. The same laws that describe how light travels through space here apply billions of light years away. This consistency is one of the most comforting facts about the universe. The laws of physics do not change. They are the same today as they were billions of years ago. They will be the same billions of years from now. Gravity works the same way everywhere. Light travels at the same speed everywhere. The strong nuclear force that holds atomic nuclei together is the same strength everywhere. The weak nuclear force that governs certain types of radioactive decay operates the same way everywhere. This means the universe is predictable. Not in every detail, of course. Quantum mechanics introduces randomness at small scales. And complex systems like weather or biological evolution are too complicated to predict precisely. But the fundamental rules are consistent, reliable, unchanging. A star burning in a distant galaxy follows the same rules as our Sunday. A planet orbiting that star follows the same rules as Earth. If we could visit that distant system, we would find that chemistry works the same way, that atoms combine to form molecules in the same way, that energy is conserved in the same way. This universality is not obvious. It is something we have discovered through careful observation and experiment. But once we understand the laws, we can apply them anywhere. We can calculate the orbit of a planet in a distant star system without ever visiting it. We can determine the composition of a star from its light without ever collecting a sample. The laws of physics give the universe structure, stability, predictability. They ensure that the cosmos does not descend into chaos, that stars do not suddenly stop burning, that gravity does not randomly reverse direction, that light does not suddenly change speed. There is something deeply comforting about that, about knowing that the universe follows rules, that it is not arbitrary, that it is not capricious, that the same processes that created the first stars are still creating stars today. You live in a universe governed by consistent laws. Gravity pulls you down toward the Earth. The air you breathe follows the laws of thermodynamics. The light you see follows the laws of electromagnetism. All of it working together. All of it following the same rules that have governed the cosmos for billions of years. You can trust in that consistency. You can rely on it. The sun will rise tomorrow. Gravity will still work. The laws of physics will remain unchanged. And you can rest knowing that the universe is stable, reliable, predictable. In the very distant future, the universe will be a very different place. All the stars will have burned out. All the black holes will have evaporated. The universe will be cold, dark, and empty. But that future is so far away that it might as well be infinite. The last stars will burn out in about 100 trillion years. That is more than 7,000 times longer than the current age of the universe. Between now and then, countless stars will be born and die. Countless planets will form. Countless galaxies will collide and merge. The universe will be active and vibrant for trillions of years. And even when the stars burn out, the universe will continue. It will not end. It will simply enter a new phase, a quieter phase, a colder phase, but it will still exist. Some theories suggest the universe will expand forever, cooling and diluting until there is almost nothing left. Other theories suggest it might collapse back in on itself, in a big crunch, the opposite of the Big Bang. Still other theories suggest stranger possibilities, cyclic universes that expand and contract repeatedly. Multiverse scenarios where our universe is just one among many. We do not know for certain what will happen, and we will never live to see it. The ultimate fate of the universe will play out over timescales that make human history seem like a fleeting instant. But there is something comforting about that uncertainty, about knowing that the universe still has mysteries, still has futures we can only imagine, still has possibilities we cannot predict. You do not need to know how everything ends. You do not need to understand the ultimate fate of the cosmos. You can live your life here and now, in this moment, without worrying about what will happen trillions of years in the future. The universe is taking care of itself. It has been for nearly 14 billion years, and it will continue taking care of itself long after you are gone. You can let go. You can stop worrying about the big picture. You can focus on the small picture. This moment, this breath, this night. The universe is eternal, or near enough that the difference does not matter, and you are part of it, a brief, beautiful part of it, a moment of consciousness in an ocean of time. Rest now. Let the universe continue without you for a while. It will be here when you wake up. Every atom in your body was created inside a star. This is not poetic language. This is scientific fact. The hydrogen in your body was created in the Big Bang, in the first moments of the universe. But everything else, the carbon, the oxygen, the nitrogen, the calcium, the iron, all of it was forged inside stars. Stars create these elements through nuclear fusion. In the core of a star, hydrogen fuses to form helium. Helium fuses to form carbon and oxygen. Carbon and oxygen fuse to form heavier elements: neon, magnesium, silicon, iron. When a massive star reaches the end of its life, it explodes in a supernova. This explosion releases all the elements it created, scattering them into space. These elements become part of nebulae, clouds of gas and dust, and from those nebulae, new stars and planets form. Our solar system formed from such a nebula about 4.6 billion years ago. The material in that nebula came from earlier generations of stars, stars that lived and died before our sun was born. That material became the sun, the planets, the moons, the asteroids, and eventually you. The atoms in your body are stardust, literally. They were created inside stars, scattered into space, and eventually incorporated into the Earth and into you. You are connected to the cosmos in a very real, very physical way. You are not separate from the universe. You are part of it, made from it, woven from the same material as stars and planets and galaxies. When you breathe, you are breathing atoms that have existed for billions of years, atoms that have been part of stars, part of planets, part of other living things. Atoms that will continue to exist long after you are gone, becoming part of something new. This connection is permanent, unbreakable. You are part of the universe, and the universe is part of you. Rest in that knowledge. You belong here. You are made of the same stuff as the stars. You are connected to everything. The universe has rhythms, cycles that repeat over and over, day and night, the phases of the moon, the seasons, the orbits of planets. These rhythms are caused by the predictable motions of celestial objects. The Earth rotates on its axis, creating day and night. The Earth orbits the Sun, creating the seasons. The Moon orbits the Earth, creating its phases. These cycles have been happening for billions of years. They will continue happening for billions of years more. They are reliable, consistent, comforting. Your body has rhythms too. Your heartbeat, your breathing, your sleep-wake cycle. These rhythms are influenced by the rhythms of the cosmos. Your circadian rhythm, the cycle that makes you feel sleepy at night and awake during the day, is synchronized with the rotation of the Earth. You are part of these cosmic cycles. You are not separate from them. Your body responds to the light of the sun, the darkness of night, the phases of the moon. You are connected to the rhythms of the universe in a very real way. Right now, the Earth is rotating, carrying you through space. The moon is orbiting. The sun is burning. The galaxy is spinning. And all of it is happening at a pace set by the laws of physics, a pace that has remained constant for billions of years. You can trust in these rhythms. You can rely on them. The sun will set. The sun will rise. The moon will wax and wane. And your body will respond to these cycles, feeling sleepy when it is time to sleep, feeling awake when it is time to wake. Right now, it is time to sleep. Your body knows this. The rhythms of the universe are telling you to rest, to let go, to drift into sleep. Listen to those rhythms. Follow them. Let your body sync with the turning of the Earth, the cycles of the cosmos. Space is dark. Most of the universe is darkness. The stars are just tiny points of light scattered through an ocean of black. But that darkness is not frightening. It is peaceful, restful. The darkness of space is where stars are born, where planets form, where galaxies slowly spin. Darkness is not the absence of something good. It is the presence of something necessary, a canvas for the light, a place for rest, a reminder that not everything needs to be bright and active all the time. When you close your eyes, you enter your own darkness, the darkness behind your eyelids. And in that darkness, you can rest. You can let go of the day. You can drift into sleep. This darkness is safe. It is the same darkness that fills most of the universe. The same darkness that has existed since the beginning of time. The same darkness that will exist until the end of time. You do not need to fear the darkness. You can embrace it. You can sink into it. You can let it hold you while you rest. The universe is mostly dark, and in that darkness, beautiful things happen. Stars burn, galaxies form, planets orbit, life emerges. And in your own darkness, behind your closed eyes, beautiful things happen too. Your body repairs itself. Your mind processes the day. Your dreams unfold. Let yourself sink into the darkness now. Let your eyes close. Let your breathing slow. Let your thoughts drift away. The universe is dark and peaceful, and so can you be. Rest now. The cosmos is waiting, and so is sleep. You have journeyed through the universe tonight. You have traveled billions of light years in your mind. You have thought about stars and galaxies, about light and darkness, about time and space. But now it is time to return, to come back to this moment, to this place, to your body, lying comfortably in bed. Take a deep breath. Feel the weight of your body. Feel the softness of your pillow. Feel the warmth of your blanket. You are safe here. You are home. And the universe is all around you, vast and peaceful, doing what it has always done, existing, expanding, continuing. You do not need to hold on to any of the facts you heard tonight. You do not need to remember the numbers, or the distances, or the timescales. They will still be true tomorrow. They will still be part of the universe, whether you remember them or not. What matters now is rest. What matters now is sleep. What matters now is letting go of everything and allowing your body and mind to drift into the peaceful darkness of sleep. The stars are burning, the galaxies are spinning, the universe is expanding, and all of it is happening without any effort from you. You do not need to do anything. You do not need to think about anything. You can simply rest. Close your eyes if they are not already closed. Let your breathing become slow and deep. Let your thoughts drift away like clouds moving across the sky. You are part of the universe, made of stardust, connected to everything. And right now, the universe is telling you to rest. So rest, let go, drift. The cosmos is eternal, and you are safe within it. Sleep well. Good night.